You have 10 minutes. The ocean has just pulled back from the shore, further than you've ever seen it go, and somewhere beneath the water, miles offshore, a wave is already moving toward you faster than you can run. You don't know it yet, but the ground shook 4 minutes ago. You felt it as a distant tremor, barely worth mentioning. That tremor was the warning. The countdown already started before you knew there was one. This is what actually happens in the 10 minutes before a tsunami reaches the coast, and almost none of it looks like the movies. 9 minutes left. Here's what your body is doing right now, whether you realize it or not. The earthquake that triggered this wave happened along a fault line under the ocean floor, where two tectonic plates suddenly slipped against each other. Seismologists at the U.S. Geological Survey have mapped thousands of these subduction zones around the Pacific. And they know something crucial. When the seafloor lurches upward during a quake, it doesn't just shake the ground. It displaces an enormous column of water above it. That displaced water doesn't stay in place. It radiates outward in every direction, and near the coast it becomes a wave unlike any other you've experienced at the beach. Why does the ocean pull back before it strikes? This is the detail almost nobody understands until it's too late. A tsunami isn't one wave, it's a series of them, and what reaches shore first is often the trough, not the crest. Water gets pulled out to sea to feed the wave that's building offshore. If you're standing on a beach and the water suddenly vanishes, exposing sand and rock that's normally underwater, you are not looking at a strange low tide. You are looking at a warning with a countdown attached to it. 8 minutes left. Somewhere along this coastline, sirens might be sounding, or they might not be, because coastal warning systems are far from universal, and even where they exist, the first waves can arrive before official alerts finish processing the data. This is why coastal safety researchers, including teams affiliated with NOAA's National Tsunami Warning Center, teach one rule above every other. If you feel strong shaking near the coast, or you see the ocean behave strangely, you do not wait for a siren. The ground itself is the warning. What should you actually be doing right now with 8 minutes on the clock? Moving. Not toward your car, not back into a building to grab belongings, but on foot, away from the shoreline and toward higher ground or the upper floors of a sturdy structure. Cars get trapped in the traffic and debris that panic creates. Feet on rough terrain moving with urgency often outperform vehicles in the first critical minutes of a coastal evacuation. 7 minutes left. The wave is still crossing open ocean, and here's something almost nobody expects. In deep water, a tsunami can be moving at the speed of a jet airplane, sometimes exceeding 500 miles per hour, and yet a ship sitting directly above it might not even notice it passing beneath the hull. Why? Because in deep water, the wave height might only be a foot or two, spread across a wavelength that can stretch for over 100 miles. It's the shape of the wave, not its danger, that's invisible out there. Everything changes as the wave approaches the coast. This is the part marine geologists find most important to explain, because it's the part that defies instinct. As the ocean floor rises toward shore, the wave has nowhere to spread its energy horizontally anymore, so that energy goes vertical instead. The wave slows down, but it also grows, sometimes from a barely perceptible ripple in the open ocean into a wall of water tens of feet high by the time it reaches the beach. Speed converts into height. That's the physics, and it's merciless in how quickly it happens. 6 minutes left. If you're on foot right now, your instinct might be to look back, to see how close it is, to try to gauge your odds. Emergency responders trained in tsunami evacuation consistently advise against this. Every second spent looking is a second not spent climbing. Elevation is what saves you, not information about exactly when the wave will hit. If you can reach even the second or third floor of a reinforced building or genuine high ground, your odds of survival climb dramatically compared to staying at street level. 5 minutes left. This is roughly the point in real historical tsunamis where the first wave, not always the largest one, begins reaching the shallows. Survivors of major tsunami events, including the 2004 Indian Ocean disaster studied extensively by coastal engineers and disaster researchers, often describe a strange quiet in these final minutes. Birds go silent. The usual sounds of surf disappear because the water has receded so far. Then a low rumble starts, one that witnesses frequently compare to a distant train or a jet engine, growing louder as the wave approaches. 4 minutes left. Why do people so often underestimate what's coming even when they can see the wave in the distance? Psychologists who study disaster response point to something called normalcy bias, the brain's stubborn tendency to interpret an abnormal event as something ordinary for as long as possible. A rising wall of water on the horizon gets mentally filed as big wave instead of existential threat until it's dangerously close. This is part of why coastal communities that survive tsunamis tend to train evacuation drills repeatedly, so the body moves before the brain finishes arguing with itself. 3 minutes left. If you've made it to higher ground or an upper floor by now, you're not finished. Tsunami waves arrive in a series, sometimes with the second or third wave larger than the first, arriving anywhere from minutes to over an hour later. Coastal safety agencies are unambiguous on this point. You do not return to the shoreline until official word confirms the danger has passed, no matter how calm the water looks between waves. 2 minutes left, and this is where the wave's true danger reveals itself. And it isn't simply the wall of water people picture, it's what the water carries. Cars, boats, entire structures get swept inland with the surge, turning the flood itself into a field of high-speed debris. Coastal engineering studies of tsunami damage consistently find that debris impact, not just drowning, accounts for a significant share of injuries and structural destruction during these events. 1 minute left. If you're on solid, elevated ground, this is the moment the 10-minute countdown that began the instant the earthquake struck finally resolves. The wave makes landfall. For someone who moved immediately at the first sign, whether that sign was the shaking ground or the strangely retreating tide, this is survivable, and often is survived exactly because they didn't wait for confirmation before they moved. Here's what all of this actually means for you. Standing on a beach on an ordinary day, you will likely never get a 10-minute warning delivered as clearly as a countdown. What you'll get instead is a tremor that feels stronger than usual, or an ocean that suddenly looks wrong. The entire 10 minutes hinges on that first moment of recognition, and whether you treat it as noteworthy or as an emergency. Every survivor account, every piece of research from coastal disaster agencies points to the same conclusion. The people who live are usually the people who moved first and asked questions later. You had 10 minutes. Most of it was decided in the first 30 seconds, the moment the ground shook or the water pulled back, and you either recognized it or you didn't. That's the real countdown, the one that starts long before anyone tells you it has. And the only version of this story that ends well is the one where you're already moving before you finish being sure.